In this video, we're going to take a look at geometric sequences and extending those sequences and also finding specific terms within those sequences. So geometric sequences are sequences in which we go from one term to the next by multiplying by what's called a common ratio. In other words, to go from one term to the next, we're multiplying by the same thing each time. So as we look at this first one, let's say that we want to find the next three terms in this particular sequence. Well, first thing we have to do is find that common ratio. So we have to know what is being multiplied by this one to get to that one. Well, if we look at that, negative 5 times what gets me negative 10? 2 will get us negative 10. Then if I look at the next one, negative 10 times 2 gets me the next term, and so on. Now, sometimes it's not always that obvious, just sitting there. We can find that common ratio if we know that it's a geometric sequence by taking the second term, dividing it by the first. That will give us the common ratio, which we can double check, make sure that that's what it is, being multiplied, and then we can use it to extend our sequence. So in this case, we said that to go from one to the next, I'm multiplying by 2 times 2 times 2, and so on. So to get the next three terms here, I'm going to multiply negative 40 by 2, which is going to be negative 80. Then negative 80 times 2, which would be negative 160. And negative 160 by 2 would be negative 320. Okay? So that's how we can extend a geometric sequence. Alright, let's take a look at this one. This one maybe isn't quite so obvious as we just look at it. We go 40, 10, 5 over 2, 5 over 8. I'm not quite sure. So let's take the second term and divide it by the first. So that would be 10 divided by 40. I'm going to look for my common ratio here. 10 divided by 40. If I simplified that, that would be 1/4. So that means I'm multiplying by 1/4 to get from one term to the next. Let's just double check, make sure that's the case. So 40 times 1/4, yep, that would be 10. 10 times 1/4 would be 10 over 4, which would simplify to 5 over 2. Then 5 over 2 times 1/4 would be, let's see, multiplying fractions just straight across top and bottom. So 5 times 1 is 5, and 2 times 4 is 8. So yeah, it appears we're multiplying by 1/4 to get from one term to the next. So let's say I want the next three. Okay, so I'm going to take 5 over 8, and I'm going to multiply that by 1/4. Remember, to multiply fractions, just go straight across. So my next term is going to be 5 over 32. Okay, then I'm going to take that term, multiply it again by 1/4. So 5 over 32. Oops. 5 over 32. Not cooperating with me here. Times 1/4. Well, on top we're going to have that 5 again. And then on the bottom we have 32 times 4, which would be 128. Then, to get my third term, the next term, I'm going to multiply again by 1/4. So 5 over 128 times 1/4. That's going to give me on top 5. And 128 times 4 is going to give me 512. Okay, so there's my next three terms. So geometric sequences can both get larger and get smaller depending on what we're multiplying by with our common ratio. Okay, now that's one method for coming up with a specific term in a sequence, but we also have a formula that we can use. And that formula is this: a sub n, so the nth term, equals a sub 1, which is the first term in our sequence, times r, which is the common ratio, and that's to the n minus 1 power. Okay, so sometimes it's going to want a term that's not maybe it might take a little bit more work than we'd like to come up with it if we just want to list them out. So we can use this formula to figure out directly what that term is. Okay, so here we have a list and it wants to know the 7th term. So what I could do is just go ahead and figure out what that common ratio is and multiply it until I got out to the 7th term, but I want to use this formula. So to do that, I need to know the first term. Well, that's going to be 10. The common ratio r. How do I find that again? Remember, to find that common ratio, we take the second term divided by the first. So 8 over 10, which is going to be 4 over 5, or 0.8. Okay, so our r in this case is 0.8, or 4 over 5. Okay, and n is the number of the term that I'm interested in. So in this case it's 7. So let's go ahead and fill those things in. A sub 1 is the first term, so we have 10 times r, which is 0.8. That's our common ratio. Then that's to the n minus 1. I'm interested in the 7th term, so it's going to be 7 minus 1. Okay, then we just go ahead and simplify here. So I've got 10 times 0.8 to the 7 minus 1 power, which would be the 6th. Now, when we grab our calculator to do this, here's my suggestion. Some people like to put the whole thing in into their calculator, and what I say to you is be very careful, because remember, the order of operations says that we need to take this 0.8 to the 6th power first, and then we multiply by 10. Well, sometimes, depending on your calculator, you might put in 10 times 0.8 to the 6th power. It might multiply those first and then take that answer to the 6th power. So be careful. Make sure you know exactly how your calculator works. And like I said, to be extra careful, we could just start over here, take that 0.8 to the 6th power, and then from there do the multiplication. So if I do that, 0.8 to the 6th power is equal to, so I have 10 times 0.262144. Now, you don't necessarily have to write that out, and be careful here. Just leave that in your calculator and then do that multiplication. Don't round if we don't have to, and in this case we definitely don't have to. I'm just writing it out there so that you can see what it is. So then I multiply that by 10, so times 10, and that's going to give me 2.62144. Okay, so that's our 7th term, and we could verify that by multiplying by 0.8 until we got out to that 7th term. Okay, then let's take a look at this one over here where we are asked to find the 9th term. Okay, so again I'm going to use my formula. I'm looking for a sub 9, the 9th term. I need to know a sub 1, the first term. In this case the first term is 1, so I have that. I also need to know that common ratio r. Well, to find that again, remember, take the second term and divide it by the first. Okay, so second term is 5 divided by 1 is 5. So that what that's saying is to get from one term to the next, we're multiplying by 5. That appears to be the case. So let's go ahead here. A sub 1 is 1 times our common ratio we said is 5, because we're multiplying by 5 to get from one to the next. And now I'm interested in the 9th term, so that's my n, and so 9 minus 1. Okay, then we're going to take 1 times 5 to the 9 minus 1, which would be the 8th. So then I'm going to take 5 to the 8th power, which is going to give me 5 to the 8th, 390,625, and there's that times 1 there. Well, that's not going to change it, so I'll just go ahead and write it like that. Okay, so our 9th term in that sequence, 390,625. Okay, so geometric sequences. Several things going on here. First of all, that common ratio. A geometric sequence is something where we multiply by the same thing, the common ratio, to get from one term to the next. I can also use this formula to find a specific term within the sequence. Remember, geometric sequences can go up or down. Sometimes people want them to go only up since they're multiplying. They think, oh, it's got to go up. Well, if we multiply by something less than 1 like this, they can go down. So they can go either way. I hope this video was helpful. We'll keep working hard on those geometric sequences in all your math, and I know you'll do great.